I'm gonna just focus on showing you how an electric motor works. So I found this computer simulation in the internet in YouTube, so I'm gonna use it to explain it to you. So what you're seeing there in this picture is a battery, so that's the green box there. The battery is connected to the coil, which is the yellow loop there, by these white wires. So there is a couple of wires that contact this coil at the top and at the bottom, right? So let me show you that. All right, so there is a wire here and there is another wire here. So the current is going to be flowing out of the positive terminal of the battery, and it's going to go out of the positive terminal of the battery. It's going to go down this way. It gets into the coil this way, flows that way, flows around, comes back this way, and into the battery, into the negative terminal of the battery. So that's the direction of the current flow at this moment. So the thing about a current in a magnetic field is that a wire that has a current in a magnetic field experiences a force. Remember that? So if we look at the force acting on the top wire of this coil, what do we have there? So that top wire, let's draw it this way, and that top wire at this moment has a current flowing that way, right? Now there is a magnetic field surrounding that wire produced by the magnet, and that magnetic field is pointing this way. So we can use the right-hand rule to figure out in what direction is the magnetic force acting on that segment of the coil. So remember that the right-hand rule, you use your thumb, you put your finger at 90 degrees with your thumb, and you put your middle finger at 90 degrees. That doesn't look super good. At 90 degrees with the other two. So this is going to be the current, this is going to be the magnetic field, and this is going to be the force. So try placing your hand with your fingers stuck in those positions, but orient your thumb with the current, orient your index without changing the shape, that's very important. Orient your index in the direction of the magnetic field. You're going to have to twist your hand a little bit to be able to do that, but if you manage to do it, you'll find out that your middle finger ends up pointing into the page. This is the magnetic force acting on that wire at that moment. So that is what you see here with a green vector. In this simulation, they're showing you the force acting on the top wire of the coil. They're showing it as a green vector. Notice that the green vector is pointing towards the back of the screen. So that is the result that we got. The force is pointing into the page, or in the simulation towards the back. So that is the force acting on the top part of the wire. Now let's take a look at what is the force acting on the segment at the bottom of the coil. So the segment right here, what is the force acting on that one? So let's figure it out again using the right-hand rule, just to verify that the answer is just the direction in which they're showing us the green vector acting here. So let's verify that. So the bottom wire has a current flowing this way, and the magnetic field is pointing this way. So try the right-hand rule again with your thumb in the direction of the current, your index in the direction of the magnetic field. The middle finger, if you hold your fingers at 90 degrees with each other, your middle finger is going to be pointing out. That is out of the page. In the simulation, you see the green vector at the bottom showing you the force, and it's sticking out towards the front of the simulation. So notice that at this moment, this coil has two forces acting at the same time. The force on the top is pushing the coil towards the back, and the force acting at the bottom wire is pushing that bottom wire forwards. So those two forces basically are putting a torque on that coil, right? If we look at the situation more from a kind of a profile view, a little bit more of a profile, we see that the force at the top is pushing this way, and the force acting on the bottom wire is acting this way. So that is going to make the coil spin in this direction. So let me play the simulation. a little bit so you can see that. All right, so that's the direction in which the coil is going to turn. Now something important happening here is due to what's called the commutator. So let me stop this at the right moment, right there. So at this moment, as we just discussed, the force at the bottom of the coil is forwards towards the front, and there is a force on the back, another force on the back. Right. Now, if we advance this a little bit, there's a moment where the force disappears, because now when the coil is completely horizontal, this wire, oh, sorry, didn't mean to run it. There's a moment right here when the two forces disappear, and the two forces are disappearing because the white wires carrying the current from the battery are connecting to that red insulating material in between the contacts of the coil. So at this moment, this is the moment when the direction of the current in the coil is going to flip from one direction to another. So the current before that moment, let's go back a little. At this moment, the current is flowing. So at this moment, notice that the current is flowing this way. Okay, so the force is consistent with that. This vector is consistent with the current flowing in that direction with the right-hand rule. But as we advance the motor just a tiny bit and we go past the gap, let's go past the gap a little bit. Notice that the current is now flowing in the opposite direction. Notice that the current is now flowing in this direction. Let me do it in white. The current went from being to the left to now flowing to the right. So that has flipped the direction of the force. Now notice that the force on that wire is pointing towards the back of the motor. Okay, so this flipping of the direction of the current was important to keep the forces acting on the coil always pushing the coil in the same direction. To keep the forces acting in producing a torque on the coil always in the same direction. That's not a good picture. The forces are always towards the back on the top of the coil and towards the front at the bottom, and that is always the case, and that always makes the coil spin in the same direction. So just to summarize, the basic principle that is acting, that explains how an electric motor works, is the idea that we already discussed, that a current in an electric field experiences a force. So when you put a coil in a magnetic field, that coil, if you are clever enough to set up this commutator, the way we're connecting the coil to the wires of the battery is using this little device, if you use that commutator, you will be able to keep the torque pushing the coil to rotate in the same direction. Okay, and that's very important for an electric motor, to be able to spin in a particular direction continuously. All right, so that's the basic idea with an electric motor. I hope that was clear enough. I'll see you in the next video.